Hello, algebra students. It's Mr. High. I'm going to show you some examples of how to solve quadratic equations by graphing. We're going to start off with x squared minus 6x plus 5 equals 0. First thing we do is we write the related function where we replace y with 0 with y. So the related function that we're going to actually graph is this. Now we have to find our axis of symmetry and our vertex. So axis of symmetry, x equals negative b over 2a. Negative b would be positive 6 over 2 times 1. So that ends up being 6 over 2. So our axis of symmetry is 3. So we'll graph that. Right there. Now we need to find the y-coordinate of my vertex. To do that, we take the equation and we replace x with 3. So 3 squared minus 6 times 3 plus 5. 3 squared is 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5. That equals negative 4. So the y-coordinate of my vertex is negative 4. My vertex is at these coordinates, 3, negative 4. So I'm going to plot that. There's my vertex. Now I need 2 points either on the left or on the right. I'm going to go to the left because I can use 2 and 1. I'm going to make a little mini table of values here. I'm going to use 1 and 2 for my x values. I'm going to plug in my equation. So this is going to be 1 squared minus 6 times 1 plus 5. 1 squared is 1. 6 times 1 is negative 6. So 1 minus 6 is negative 5 plus 5 is 0 for y. When I plug in 2, 2 squared minus 6 times 2 plus 5. That's 4 minus 12 is negative 8 plus 5 is negative 3. So now I need to plot those 2 points. So 1, 0 right there. Make that a little bigger for you. And 2, negative 3. And then I reflect those. And I draw in my parabola. The solutions of this thing are the x-intercepts of this graph. So this one intercepts the x-axis at 2 different points. It intercepts it at 1 and at 5. So my 2 solutions are x equals 1, x equals 5. Let's do another one. Again, start by writing the related function. We have to get 0 on one side first. So negative x squared plus 2x minus 1 equals 0. I take that 0 and I replace it with a y. Here's the function that I'm going to graph. So let's do our axis of symmetry first. Negative b over 2a. Negative b is negative 2 over 2 times negative 1. So we get negative 2 over negative 2, so we get an x-coordinate of 1. Our axis of symmetry then is going to be at positive 1. Now we need our vertex. So we plug in 1 to our equation, so negative square 1, 2 times 1 minus 1. 1 squared is 1, but then we have this negative, so it's negative 1 plus 2 minus 1. Negative 1 plus 2 is 1. 1 minus 1 is 0, so our vertex is at 1, 0. Right there. Now let's do our little mini table. I'm going to choose 0 and negative 1 for x. when I plug in 0, that's the easy one. Both of these are 0, so it's -1. Plug in -1. -1 squared is 1, and then the negative outside makes it -1, plus -2 is -3, -1 is -4. So we'll plot those and we'll reflect them and we'll see what happens here. 0, -1, -1, -4, reflect them. My parabola, it looks like, touches the x-axis in one spot. It touches right at my vertex, which means I only have one solution in this one, and it is my vertex. So x would equal 1. That's the only solution, the only spot it touches the x-axis. One more. Again, we have to get it to equal 0, so we have to subtract 4x from each side. X squared minus 4x plus 7 equals 0, so the related function is this. Let's find our axis of symmetry. X equals -b over 2a. Negative b would be +4 over 2 times 1. So that's 4 over 2, which is 2. Let's graph x equals 2 is my axis of symmetry. Right there. Now let's go ahead and find the vertex. Y equals 2 squared minus 4 times 2 plus 7. So 2 squared is 4 minus 8 plus 7. 4 minus 8 is -4 plus 7, +3. So my vertex is at 2, 3. Let's plot that point right there. Now I need my mini table of values. I'm going to use 1 and 0 for x. When I plug in 0, that's the easy one. I just get +7. Plug in 1. 1 squared is 1. This would be -4, so 1 minus 4 is -3, plus 7 is +4. Let's plot those and reflect them. So 0, 7, 1, 4, reflect them. This parabola does not intercept the x-axis at all, so this one has no solution. And that is how you solve quadratic equations by graphing.